Wait, is that your computer or the school computer?
Oh, it's on my computer. I bought
Okay,
this
okay.
yesterday. Bought this yesterday for this class specifically.
Okay.
Where'd you get? What's the spec?
Oh shit, like 50, 70 or something.
Oh, nice. That's nice.
It looks nice.
It is.
This one has problems. Your old one was going to
I know.
very soon.
I don't know. I'm assuming it's 16 gigs of RAM, right?
Maybe.
Oh, nice.
I know.
That's crazy.
I need to still upgrade my RAM. 'Cause I got the one for 16 gig. 'Cause I couldn't get the 32 one, but I
Yeah.
just upgraded.
Yeah, I got a good one. My last one was.
Oh, not your CPU. The CPU is pretty important for this kind of kind of work.
I don't know, whatever one we needed is what I got.
Yeah, that's kind of how I
That's
do
not
my
very
stuff.
specific, and also you try to get something that will last you like a couple years. So
Well, I'm gonna assume if you got something with 32 gigs of RAM, the CPU is probably also good.
Oh yeah,
Yeah,
this
this
not
new-
necessarily.
this puppy is good.
Not that I'm
If
saying.
it'll let me get into it. You need internet to log in, dude. I don't have the casino. Mom, I have to try.
It's like doing the Windows setup. Like, it hasn't done that stuff yet.
No, like I've done all that.
Oh, okay. All right.
Oh my
Just log into
god.
the computer, get to your desktop, and log in.
Oh well. Doesn't sound ideal.
Okay. How's everybody doing? One of these days, I want to ask that question, and people will be like, "Yeah," but no, especially no evening class has responded in that
I
way.
actually hate that question because no one answers it truthfully except me. Like, what's the point of asking a question if it's scripted?
Okay.
I feel bad if I was like, no, I'm doing terrible.
People definitely say that occasionally.
I got my position.
Okay, let me do names again. Arlinka, and let's go this way. Maya, Arlinka, Maya, like KJ, Max, Punchy, and then Jana. What's that? Jana. Okay, Jana, Finch, and MJ? No, Montana. I got the M. And you sat next to MJ at the other morning class, so I grouped that together. Montana. Okay. Maya. Montana, Maya, Punchy. Okay, great. Okay, and everybody's been getting everything in on Discord and responding to everybody else. Excellent. The last week's assignment is due tomorrow night, right? Everybody, yes, understand that? Okay, good. And so what I'm going over today, like we're going to build on that, but what we do today, you don't have to put into what's due tomorrow night, right? Like what's due on Tuesdays is usually the week before stuff. But last week was truncated. We're going to build on it this week. So if you're still working on that, which I imagine most of you are, and then you incorporate some of this stuff in, that's fine for this week. But as we go forward, there'll be a little bit more discrete barrier between those things, but we have this pattern going forward. And then Fabio, our tutor, is on the chat there as well. And then did I announce his hours last week in this class?
I think you did.
I did?
I remember.
Arlinka remembers. Does anyone else remember? Because you were in the...
Posted on Discord.
You're on Discord? Okay, good. Yeah. Tuesdays and Thursdays. Well, I'll just look at Discord. What did he say? Tuesdays and Thursdays 10 to something? Ba, ba, ba. Ba, 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 ba. Okay. Did he post his intro video thing yet? I'm not sure he did. Okay, great. And then I assume everybody else is coming through, and everybody had done their syllabus acknowledgement quiz, so we're all good there, which is great. Okay. And then, yeah, for this week, I'm having you guys make the presentation video, and so we can play those back. We'll look at those first thing on Wednesday, right? But I didn't have you all also post your bouncing ball on Discord because, you know, they're all going to be pretty similar. Usually, I'll have you also post the assignment on Discord so that you guys can comment on each other's stuff there. But, you know, this week, you know, like, great bouncing ball, you know, like, and everyone, this is the first semester we're putting all the intros over on Discord, so everyone's been interacting on Discord. I'm happy with the level of Discord activity. So we don't need that happening right this second.
It's not a good idea to have chaos in the class.
What do you mean?
Discord.
Oh, yeah.
But
I'm totally even not even thinking about that name anymore. But yeah, that's a good point. Okay, great. Okay, let's look at a few things here. I'm going to save this, and we're going to move forward with a couple things here. And yeah, I'm going to come over to scenes, and I'm going to move this over so that you can see what I'm doing, and right click and say create scene, right? So it gives me a new scene file here in the same project, right? So just to be clear, in Unity, right, we have a project, and that's essentially the folder. And then inside a project, there can be multiple scenes, scene 1, scene 2, so on and so forth. Most of the time, these end up being separate levels in a game, especially smaller games, like each scene would be its own thing there. And we have that. So I made a new scene. If I double click here, let's name it. This is going to be interactive examples. And let's double click there. Okay. And we're good. Let's go into a few other things. All right. So I had to rush over a bunch of things just with one class last week, and we'll sort of slow it down. And we don't have to go through all of the introduction stuff. And so here's what you see usually when you just open a default Unity scene. We've got our camera and the main directional light. If I were to delete the light or actually just turn it off, you'll see that this happens. And so this is interesting and noteworthy in that, well, if I turn off the light, how come I can still see stuff in the scene, right? Because there's no light. What's going on here? The scene itself, because this is a real-time rendering environment, right? That we're rendering the stuff in real time. It has to be super, super efficient, meaning the computer has to be able to calculate at least, 30 frames a second. And because of that, the lighting, real time, more or less, we need to fake everything. We see a lot of really great computer graphics stuff now in movies where things look very, very realistic and high fidelity, right? The thing about making a movie is that you can do what's called offline rendering, meaning that you can tell the computer, I want this to look really good, take as much time as you need to make this one frame, right? We're working in an environment where we want to have interactivity, and so we can't use this. We need to use real-time rendering. And because of that, this is going to be the major reason that there'll be things in this class that I say that are different than, for instance, 185 or 184, the intro to animation, because we need to have things happen in real time. And so certain things about mostly rendering stuff. So lighting, reflections, light, the environment. There's all sorts of techniques, but also kind of computer graphics tricks that need to be relied on in a real-time environment in order to make it happen at least 30 FPS. Right? What does FPS stand for? Frames per second, right? And everybody's a gamer, ideally you want your games to run at least 30, right? 60 is usually what everybody, wants to have happen, or if it's really critical, you have a great machine and everything, you can run things much, much faster. And so I just went through this spiel in the other classes. Here in AVC 200, since we are in this real-time environment, FPS is flexible, okay? How fast does Unity render? As fast as possible. Without going in and making any changes, Unity will try to show you as many frames as it can, depending on the complexity of what it is you're asking it to do. So in other classes, like when you make something in Blender and you render it, you say, Blender, render this at 24 frames per second, render this at 12 frames per second. And it'll just take however much time it takes and do that. Here, the more you ask it to do, the more this will decrease. And you can, push it to a point where it would be less acceptable, right? Like something below 30 frames a second starts to really, not be, we'll start to feel a difference in the interactivity, right? Now, that depends in terms of what is the interaction, right? Am I like flying a jet that's going 1,000,000 miles an hour through an environment? Well, then the FPS needs to be pretty high, right? If am I just pressing a button for a Flappy Bird game, right? Well, then that's a different level of interactivity in terms of the delay and feel for that button. So, everybody with me there? This is part of the reason we're still seeing the environment up here. Is because even though I turn this light off, we still see stuff up there, is because this light is only part of the overall lighting scheme. If we come up to window, and then actually first I'm going to make some stuff. And so let's make some stuff. I'm going to make it's really annoying that this window keeps appearing on my other screen for some reason. I'm going to make a plane, and then I'm going to make some sphere, and to have it on the playing field, I'm going to also make a cube. There we go. All right. And so I've got those there. All right. And got this. And I've got something like this set up. I can move these things around. Again, not Arlinka. What is red? Which axis is red? You got a 30% shot. X, Y, or Z? X. Green? Y. And blue? Z, right? And so those of you coming from Blender, Z is up in Blender, right? So you're used to that. When you get to Unity and many other programs, Y is up in Unity, right? So when you make a Blender model and bring it over, this will be one of the things you need to compensate for when you bring it over into Unity, making sure the axis is pointed in the right sort of direction there, right? And then our tools, WER, cycles between our move, rotate, and scale over here. And Control D gives me easy duplication of the objects if I were to make more objects here. And let's move this up. Because all of these things over here, what's the name for all these over here on the left? What are all the things that appear in this list are what's that?
Primitives?
The plane and spheres are, but even more general than primitive. What are all these things over here? Game, objects, game objects, right? And so they can be created and destroyed dynamically during the game, right? All of this stuff down here, what was the name for all of these? It's on the screen. Assets, right? These are all assets, right? And so these are files. And so what do we not want to do arbitrarily down here? Delete stuff, right? Because you're actually deleting a file, right? And so during the game, certainly in the games we make, we're not going to be arbitrary. You're not going to be creating and destroying assets, right? Once you make the game, all the assets are, included in the game package at that point.
It's No Man's Sky.
Right. And then you're downloading more stuff as it goes on. But great. Okay. So game objects, assets, right? And just to review this, right? If I go into play mode here, and then I were to delete objects in play mode, and then I come out, they reappear, right? Why is that? Right. And during play mode, things can be created and destroyed, but when you reset the game, they go back to where they were at the beginning, right? And so if they weren't there, they get returned, or it's possible to create things during the game as well, like spawn them. And so things spawned during the game, right? Like we'll make enemy spawners that'll spawn enemies during the game. And like when we go out of play mode, the spawned enemies will go away, right? But they'll be respawned the next time we play the game. Great. And the problem there is that you can just go into play mode often and not forget about it, which is why we did the thing where we tinted the viewport, right? Everybody do this already on their home machine? So you got the viewport tint in there. Again, that was under preferences, colors, play mode tint.
What version of Unity are we using?
You guys have 6.3. They haven't installed 6.3 on the computer here at school, but it should. I'm on 23. Unity used to go by numbers, meaning it was like Unity 4, Unity 5. Then like 5 years ago, they're like, we're not going to do that anymore. We're doing the years. Unity 2021, 2022, 23. And then last year, they're like, know what? We're going back to the numbers. And so like 2023 is right before Unity 6. So yeah, it's a mess. But yeah, hopefully they stick with this going forward. It makes more sense because even when they started numbering by the years, they never kept up with like the actual time it was. And so in 2024, you were using 2023. And so just hence going back to the numbers, which is a little more forgiving there. So yeah, you guys download, like I said in the assignment, 6.3 is the new one, right? Because in 6.1 and 6.2, there was like some sort of esoteric security problem. And if you had those installed here, they may come up. It looks really alarming. Like there's like a whole bunch of red text here saying like security alert. That security alert is only if you published a game with that version of Unity, then you should probably patch that game so the people you downloaded your game don't have that security hole. It's not a big deal for our closed situation there. Great. Okay, so here. Let's look at this. We've got a bunch of objects. Let's put some materials on them so I can drag the materials onto this. I'm gonna another good one for the assets is control drag, is a copy drag down here in the asset area. And so like I need a new material, I could right click and then search for new material, or I could grab the blue one and just control drag it down. And now I get blue 2, which I could change to something else, and then probably change the name of it to green. And now I've got some different materials I could use to add some color to this scene. I don't know why it doesn't like me dragging it onto that sphere. Let's try it over here. Oh, I think there's 2 on top of each other, which is why that was weird. There we go. Okay, great. So I've got some stuff in the scene. Now, let's go ahead and we got game objects over here. We got assets over here. And then over here, our other main vocabulary, we have the cube, the mesh filter, the mesh renderer, the collider. What's the name for all of these things? Components, right? Components go on game objects, right? It's important to know there's a little bit of vocabulary here for when you're reading the Unity documentation. This is how they'll refer to things. Game objects have components, and so all these things have different components on them. And our scripts become components eventually. Good. Let's look at some new components here. For instance, I'm going to go ahead and grab the camera. And so over here, we've got the camera in the scene view, right? So again, in your notes, scene versus over here, the game view. This is what the player sees. Sometimes you can put all of this, dock it all there. And so if you're working in the scene view and you hit play, it'll switch over to the game view, right? Or you can stop this and move this over so that you can see both at the same time. That's usually how I like to have it set up, so I can see what I'm doing. And then if I move this, it moves the actual orientation in the game, like so. The other way to take care of the camera is more like in Blender. And so let's say I want the view to be more like this angle. And so here, the way to do this is to set your scene view the way it is that you want, select the camera, and it is Control-Shift-F is going to move the camera, actually any object we have selected, to the scene view. So this is the easiest way to place a camera, rather than selecting the camera object and trying to use all the tools to move it around. So if I grab the camera here and I go Control-Shift-F, boom. Now the view in the game is wherever I had my view over here. So this is super useful to be able to move stuff around and see what's happening. And let's keep going here with this. Let's add some components that move around. That'll be a little bit more exciting. We've got our cube. I'm going to grab this cube here, and let's do something to that. I'm going to move this up. And nothing's really happening in our game, but one of the main things we can do here, move things. We did one last week. We animated with keyframes, right? And that used the animator and animation clips. We can also use physics. The physics engine, there's both a 2D and 3D physics engine that's part of Unity that are there kind of running all the time. And we can sort of opt in and opt out of them. And the way that we'll do this here is that we can add the rigid body component. That's going to be the thing that sort of puts something into the physics system. So if I come back to this cube here and come to add component and I search for rigid, there it is. We're in 3D, so we want this one, okay? Not the one that says 2D. Unfortunately, the 3D one does not say 3D, it's just blank. So if we come over here and say rigid body on this cube here, okay? And so now, if I go into play mode, hold on. Ba-da! That was pretty cool, huh? I mean, stay calm. Stay calm. But, yeah, mind blown. So this one now has, simulated physics here. Right, so this is one way things can be interactive in the game. So for instance here, this one fell, the other ones did not. And so there's a little bit of a formula here. If we have a collider only, it's going to be stationary. If we have a collider plus rigid body, that is going to move with the simulation. If we don't have a collider or rigid body, this is not in the system. So when you just make a default primitive of any kind, I think all of them, a cube, a cylinder, anything, by default, they'll have some sort of collider on them, okay? But if I take the plane here, and you notice that it has the mesh collider, which I will turn off and then hit play. Goes through the floor, right? Because now the floor is still visible, but not in the physics system. It doesn't get counted there for that. If we were to select these objects here, the collider defines not only the hitbox for object interactions, but also the hitbox or sort of physics box for this kind of simulation stuff, right? So for instance, with this cube, let me turn that back on. So on the plane, I'll turn the collider back on, right? What if I did this? I'm going to go to the plane and add a rigid body. And now two things have a rigid body on and collider, this and this. And so what's going to happen when I press play?
Maybe the plane will fall down as well.
Yeah, good guess. Or I'll get an error. What is it possibly telling me here? Did I click some other box I shouldn't have? There we go. Right? Obviously, that's not what, most of the time on a floor object, that's not going to be the case. So I can right click and say remove component. And so that's out of there now. Great. So let's make it a little bit more interesting. So I'll take this and sort of rotate it at a strange angle just so it moves a little bit differently. And then I'll come back and select this. And we talked a little bit about this morning in 185. I've got this sort of randomly rotated cube. And so now if I, hit play, it'll fall to the ground, but it will do, it'll move a little bit when it hits, right? Like you would expect. But let's say I wanted some more of these, and I wanted to move it straight up. Well, if I hit Control D, now I could do, if I select it, Control D, and then I can do this one. But if I look at it from the side, okay, now I got to move it this way a little bit. I want to move it straight up. And so I want to change the axis orientation from local to world. And so now that's going to be up here, right? See where it says local? I'm going to switch it to, that is also appearing in my other window, global or world. And so now the axis is straight up. And so I can Control D and do something like that. For instance, there we go. And let's see that. Ta-da, right? Another fun thing with the physics system is overlap equals explosion. So just like the real world, two objects cannot occupy the same space at the same time. And if you have overlapping objects, it'll push them apart. If they overlap more, it'll push them apart with more velocity. And so this one here, I'll just Control D a bunch of times. And so now there's a bunch of cubes that are in the same spot right here. And so now if I run this, explosion, stuff everywhere. And the more they overlap, the more they get pushed apart. So those are all completely overlapping. If they overlap just a little bit, it'll be slightly less explosion.
It's like the speedrunner's dream if they can find something in the game that can overlap like that.
To sort of get the momentum of it exploding.
Either the momentum or just glitching through objects, but there's a very popular one in Mario 360 or 63 or something like that, where if you jump on the stairs at just the right angle, the stairs will push you up.
Oh, okay. Yeah, so we've got this happening now. We're able to use the physics system to make other things, move here or fall over or whatever it is that we're doing with these. Good. Okay. And again, this is all happening because these have rigid bodies on them. These do not. They only have colliders with no rigid body. Everybody with me? Okay. Here. One more thing. So the collider changes the physics, and so under the collider shape is different than the actual rendered shape. And so here under box collider size, I'll make this 555, and you can see what's happening over here, right? The collider for this cube is like way bigger than the cube itself. And so now this gigantic overlap cube is overlapping with those. And so now if we run it, everything falls off there.
That would take like 17 different steps just to do that.
What's that?
In Blender, I feel like that would just take like 17 different steps just to change the hitbox or something.
Yeah, the physics engine as it exists right now in Blender can be very there's a lot of steps to do a lot of things. So yeah, it is. Yeah, like it's very sandboxy here. It's kind of easy to make a lot of this stuff happen, which is super useful. So we're pretty good. Any questions about this basic physics engine stuff, right? Usually those are the three things you need to be able to do. Like make something have physics, make something just be stationary, right? So other stuff can sit on it, or doesn't want to be in the physics system at all, right? Those three options. Once you start animating objects, there's a couple other issues there, but I think we'll get to something close to that here soon. Let me make sure I'm not seeing what people are saying. Okay, sorry. Oh, Fabio's there. Oh yeah, Fabio put his tutoring hours in the YouTube chat there. Okay, great. Let's keep going. Let's make a much better animation of our bouncing ball. So let's get rid of some of these things. Actually, before we do that, let me address one other fundamental object issue here. Parent and child relationships. So over here, all of these objects are at the same hierarchy, and we can simply just drag them onto each other over here to create parent-child. So for instance, I'll take this thing and I'm going to just scale it up to make it visibly, obviously different. And now I'll take these other objects and make them the child of this. And so here, 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 and then I'll click and hold and then hover over. And I can't zoom in on it because I'm holding the button down, but there's a tiny little thing there to the lower right of the mouse cursor. I let go. And now there. This is now the parent of those objects right there. And so if the parent is transformed in any way, the children come along for the ride. So for instance, that's there. If I were to transform the parent object, all of the other objects that are children, but if I were to make the child object different on any kind, then I can move that independently. The parent doesn't move, but it's still attached to the parent. Right, so this concept is the same as Blender or any other program that has this idea, right? This is the beginning of how to make any sort of like multi-part thing. Cars, spaceships, characters to some extent, right? The idea that we have multiple parts that can all be addressed together, and then you can have children of children, right? So Control D, there we go. I'm going to take this one and make it a child of this one. And so now if this one moves or rotates or is transformed in any way, there we go. So here we go. This is where this concept at first glance is fairly obvious, and most of you have probably encountered this before, right? But this is what people run into, and then they're like, wait, what's going on? Right, so I have this one here, and I'm rotating this cube, but I'm getting this really bizarre scaling here, skewing as I'm trying to rotate this parent-child. It's because the top level parent that I just sort of randomly scaled while I was working on it has an uneven scale. And so this is, the positional part of being a parent-child is fairly clear. And so is the rotation, I think. It's the scale that really gets people. It's that this has been transformed. And so this ends up skewing what's going on here as we go down the hierarchy like this. So the rule I would write down in my notebook here is that the top of the hierarchy, I would ideally put the scale at some sort of even denomination, something like 111, 222, 333, right? And so again, I'm just sort of manipulating some shapes here as a way to get some examples and some things to see in Blender. But if I wanted a long rectangle, taking a cube in Blender and stretching it may not be the best approach, right? Because then we end up with this skewed scale numbers. Whereas opposed, most of the time when we're making stuff, we're going to be making meshes in Blender and then bringing those in to Unity, right? So just to be clear, most of the time, remember, Unity is where we are doing the name of the class. We're making animation and interactivity. Why would it not type an ampersand? Because I had the dial sign. There we go. There we go. Unity, animation, and interactivity. And then, but we're not actually authoring media assets. That's coming from what we want to make. Do we want to make 2D things? Well, everything is on the board there. Ideally, we want a PNG. Why do we want PNGs and not JPEGs? Transparency. Higher quality? Perhaps, usually, but that's not the differentiator. The PNG is going to have a red channel, a green channel, a blue channel, and then what is the other channel that allows the PNG to have transparency? Alpha channel, right? JPEGs, everyone put this in your notes if you don't have this internalized in your DNA. JPEGs do not have an alpha channel, right? That's why they're particularly not very good for most game design applications, right? And so any application that makes a PNG, which is virtually any drawing application, is going to be fair game. And I'm okay with you using whatever you're comfortable with, right? You're doing Procreate, right? Procreate obviously makes PNGs. I mean, last semester there were a bunch of ones I haven't even heard of. There's Llama. There's a Fire Llama. I have not used Fire Llama. Krita, right, is one people use. What other 2D drawing programs have people used?
There's one called Medibang that I know of.
Metabang, yeah. Clip Studio Paint, right? Yeah. Photoshop, obviously, right? All of these are totally fine for when we're doing 2D stuff or when you're putting any sort of 2D assets in your Unity projects, right? Because all of these programs, I mean, I'm not 100% certain, but I'm pretty sure output PNG files with a alpha channel, right? This is what you want, right? I'm not going to address every possible combination here, right? This is where the great internet is your asset in that, you know, how do I export a PNG from Metabang? I'm sure, you know, an 11-year-old somewhere has made a tutorial about that that's available on YouTube somewhere, right? And it's good that those are all there. But when we're making 3D assets, we're primarily going to be coming from Blender. And for the most part, we are going to export FBX files, right? We're not going to bring blend files directly into Unity, primarily because of the issue we just discovered at the very beginning, right? What direction is up in Blender? Z, but in Unity, Y, right? So and that is in addition to a bunch of other issues, is problematic there, right? And so we export FBXs. We're not going to do that today, but we'll probably open Blender next week and go through some of that stuff. But over here, you know, I'll bring in stuff from Illustrator and Photoshop, but I mean, I saw all the stuff coming over across on Discord, and yeah, everyone's using a lot of different tools. As long as we can get to a PNG with Alpha Channel, which you can in almost every instance, like, and if you can't, you can just bring whatever close enough into Photoshop and then Photoshop your way to a PNG, which is, how many of you, show of hands, if I gave you a random JPEG, would feel comfortable creating a mask and a PNG for that out of Photoshop? Okay, how about if I said you didn't have to use Photoshop? You just had to take, here's a random JPEG, you have to turn it into a PNG with an alpha channel. Use any tool you want. Do you feel like you could get there? Okay, good. All right, maybe that'll be in next week's homework. I will indeed provide a random JPEG that you need to somehow turn into a PNG. Okay, everybody clear here on big picture workflow, yes? Okay, later on, we'll go from here, from Blender into Substance Painter, which will allow us to do a really great job painting our meshes and then bring those materials into Unity, and they will look great. So the workflow gets more complicated, right? Yeah, and so the reason this weird skewing happens is because of this. And so ideally, you do not want your game objects having these sort of arbitrarily unbalanced scales, okay? And usually they're not, because you've made them the proportions that you want in Blender, and we're just bringing them over at the scale they are into here. But we'll get to that. Yeah, so parent-child. That's good. Okay. Now, with that in mind, let's delete this stuff and come over here and look at the lights for just a second. So there's the directional light in here. We'll spend a minute on this. So here's what I would write down. This is very similar to Blender. The directional light here is roughly equivalent to the sunlight in Blender. And Max is in the morning class. What did I tell you about the sunlight? How do you manipulate the sunlight?
Intensity?
What if I want to change the direction of it? What tool do I have to use?
Oh, the ray.
Close. It starts with an R. I have to rotate it, right? Moving the directional light doesn't do anything. It's like the sun. It's the same direction here. Watch. I'll grab the directional light, and I'll grab the move tool, and watch what happens. Absolutely nothing, right? The light itself does not change because the directional light mimics the sun. The sun is so much bigger than the Earth that the light rays are arriving in parallel. And so, and they're kind of filling the entire scene. When you have a directional light in your scene, you can't get, besides being in a shadow, you can't get away from it. It fills the entire scene. And so if I grab this and I move it around, nothing happens. If I rotate it, watch what happens. It's like I'm moving the sun across the sky, right? And if I rotate it below the horizon, I rotate into nighttime, right? And so this is the easiest way to put a day-night cycle in your game is to animate the rotation of your directional light, right? And so here we start to see a little bit of what I was alluding to previously, in that the directional light itself is linked to some of the environment settings, right? So before, when I turned the directional light off, it didn't go completely dark. But now, when I rotate the directional light below the horizon, it does get completely dark. It's because there's a link between the directional light and then the environment, and that matters here. Okay, so there's the directional light. Let's turn that off for a second. Or actually, you know what? I'll rotate it below the horizon. I'll come over to window. So you'll, for the most part, we don't need to dive into a lot of that this week, but here's where you get to a lot of the other Unity interface. And so in window, we'll go to rendering, lighting. And so this is an important window that does a bunch of stuff under environment here. The other light we're seeing is coming from this sky box that surrounds our sky. And we have this shadow color and environment lighting intensity. And you can see how this sort of turns up and down the ambient environment light. And then this is a environment reflections. You can see that goes up and down. Those are the two main things to be aware of right now. But yeah, so there's that. So look at the shadows from the environment light, from the directional light. If I were to turn this off, the other kind of light that we use here at the beginning, if we come over here, plus light, point light. And so the point light is different than the directional light in that, you guessed it, it's a point. It's more like a light bulb. And so the light, there we go. instead of going parallel, the light comes out in all directions from, this point. And if we grab the point light here, which I'll rename to point light, there we go. And I were to come over here to intensity and crank this up, we'll see we get a different thing. What else is different about the point light?
If you move it, it will actually affect the environment. Light.
It will. There's something else I'm drawing in here. What should be on the ground right here? Yes, and there is not. Shadows are optional. Shadows can be expensive. And so going back to that real-time rendering that we talked about at the very, very, very beginning, right? This is another way that games save energy, save computation for where they need it, is that you don't want to be calculating a bunch of shadows that either are not very visually impactful or more of a problem. And so unlike the real world photography class, how many of you have taken photography class, either 177 or one of the other photography classes? Right. You set up your studio, you got your soft boxes and your lights and all of your other stuff. And then you turn on a light. In the real world, you can't tell that light to don't make shadows, right? That's not, like, physics does not allow for that, right? But here we can do that because we're in this simulated environment. And this is the other thing to write down. Shadows are off by default on the point light. Everybody put that in your notes. So they can be expensive. They are optional. But one of the things that new students do a lot here is they don't have shadows, which makes their stuff look kind of crummy, right? I don't want you to be afraid of shadows here. In the most part, we're not going to run into a problem where it's going to be super computationally expensive at the beginning. But in terms of being optional, you should opt in almost all instances here at the beginning, because the shadows make it much easier, make it possible to determine the relationship between the objects. Like, how is this cube sitting on the plane or is it hovering above the plane? It's impossible to tell without having shadows. As soon as I come over here and select the light and go down to shadows and say hard shadows, now I can clearly see that there is some space between the plane and the cube. And if I move the light around, we can see what's happening there. Okay, and so now with the point light, movement for the light matters. And so in this way, it's the opposite of the directional light. Because this is one singular point, if I rotate this, nothing happens, right? Because it's just an infinitely small point in space, and it doesn't have any directionality. Light is being emitted in all directions from that point, and rotating the point doesn't do anything, right? This is true when you're 3D modeling in Blender for the most part as well. If you take one point and you rotate it, it doesn't do anything. It's a single point. It has no directionality to it for the most part. Yeah, so let's write that down. Directional light. We want to rotate, not move. And point light, you want to move, not rotate. So they're sort of the inverse of each other in that way. And the lights can be tinted, which is always fun, but making them too strong of a color tint, it always ends up looking kind of cheesy. So you may have noticed over here, the options are no shadows, which we just discussed is not a great option. Hard shadows or soft shadows. What does that mean? For the time being, hard shadows will be fine. Okay. Soft shadows, if you watch the edge of this. You see how this blurs a little bit here now at the edge? In general, this does look better, but as is true for most things in real-time rendering, it is more expensive computationally, right? So for right now, let's go ahead and say that no project, we'll put a limit. 5 light limit. You should really not put more than 5 lights in a scene for right now. Right. You should be able to do fine with that, right? So in general, if the scene is too dark, the answer is not to add more lights, it's to make the lights that are there brighter, as opposed to adding more lights. This is a common mistake for new students. It's like, I'll get Blender files and I'll get Unity projects where it's like, there's 26 lights in the scene, right? That's too, like managing that many lights is just not easy. So there you go. Okay, so far so good. We got lights. We were able to move our camera. Yeah, let me put this one back kind of like that. And the other thing, especially for point lights, we're going to want to make sure that those are, you know, above the scene. So we're going to go ahead and turn up the intensity on that. If I go up further, this is different than the real world. The light will stop at some distance from the actual bulb. In the real world, the light, you know, continues to travel and decreases by an exponential amount over a certain amount of distance. But here, the light stops. If you want to extend the range of the light, that's why there's this gizmo here in the view. And so I could make it a very bright light that doesn't go very far, like this, or I could extend this further and it's sort of a softer light. For right now, I would, under intensity, just adjust the intensity, not the intensity multiplier. That's a different thing for a different situation. Okay, some basic lighting stuff there. Questions about that? Does that make sense for what we were describing? Yeah? Good? Okay, good. Let's continue. Let's do a better job animating, and we're going to do a much more interesting animation here on a ball. And one of the things that, in terms of improving on what we had on Monday, the ball just bounced up and down, right? And so as animators, what's some other thing we could do to the ball to make that bounce better? Squash and stretch. Should be easy, right? You guys have squashed, you have both squashed and stretched in the past, right?
I never really animated before, other than doing stop motion. But
Okay.
Guys' jokes are very hard this semester.
We'll get to it, don't worry.
We'll get to it. We're warming up.
All right. So if we were going to squash and stretch this ball, here we've got our scale, which would allow us to do that. Just from a side note here, check out the collider. See how the collider does not squash and stretch when I squash and stretch the scale here, right? So that won't be super important today, but just something to keep in mind as we do this, right? And so if we were to squash and stretch this ball, we can do that by manipulating the scale here, clearly. But as we look at this here, what might be the problem given this current setup?
you need to add keyframes.
Okay, we need to add keyframes. Yeah.
That's on the right axis.
Yes. Okay, good eye, good eye. Right? The anchor point for the sphere is in the middle, right? And that's going to be not ideal for squashing and stretching something like a bouncing ball, because we're going to end up in this situation where if we bounce down to the ground like this and we squash and then we go to stretch, we need to be moving the ball to compensate for the difference, of where the anchor point is, right? And so this is generally not great. But this allows us to bring up an important part of Unity is anchor points. And the frustrating truth here is when you have a mesh, you cannot change the anchor point in Unity. This may seem like a bizarre and frustrating thing. It's because the mesh is a separate file and the anchor point is part of the mesh file. Okay? If you have a sprite, essentially a PNG, you can change the anchor point in Unity. So, important to understand this, right? Because a sprite, a PNG file, doesn't have an anchor point in the file, right? You can set it in Photoshop or in After Effects, but that's a property of the After Effects layer or whatever it is like that. Whereas the mesh file does have an anchor point. And so this creates a necessity that once we start modeling things in Blender, that we get the anchor point correct before we export to Unity. It's absolutely necessary. With that in mind, remember I gave you a project to start with, right, for this week, for what's due tomorrow. And then as we continue to work, for right now, we're going to work in that same project. Probably the week after, I'll give you a new project, which has some other stuff in it. But for right now, we're going to work in that same project, okay? Because in that project, there's the script, or actually, I had you download and bring in the script, right? But also, if you look to the meshes folder, there is a mesh in there that says new sphere, right? And if I were to bring this sphere in, the difference for this new sphere should be clear. If I drag in the new sphere here, right? So here versus here, what is the difference between these two?
Material.
Sure, one's green, but I mean,
Scratch.
The gray sphere's anchor point is at the bottom.
there you go. Exactly, right? Here, the anchor point is in the middle. Over here, the anchor point is at the bottom, right? And so that's the reason I provided this sphere to you, is that we can use this to do some proper squash and stretching because the anchor point is in the right spot. Does that make sense for everybody? Right? Okay. Cool. Let's save. And so I bring in new sphere. And let's also look at some of the other differences. This is important to take note of. This is a mesh. This is not a Unity primitive. It is a mesh that I made in Blender and moved the anchor point, and then is already in Unity here. We imported it. Use this one. Don't make your own in Blender, because exporting from Blender to Unity is another bunch of stuff we need to talk about later. Okay, just use this one that's here. But notice it does not have a collider, right? So if we wanted this thing to have a collider, we would need to add that, right? So if I were to do this here, and does this one have the rigid body? No, we'll add it. There we go. And I'll move this over here and move this up. And so now, there we go. If I were to hit play on this, like so, right, it goes through this sphere, because this sphere does not have a collider on it. If I were to grab the sphere here and then add the sphere collider, now if I hit play, it will respond more like you would expect. Boom. Make sense? Awesome. Great. Good. Okay, so let's get this animating. And I'm going to clear the table. And so I want to put the sphere back at the origin. And so I'm going to, this is a really good one. In the transform component, up here at the right-hand corner, there's these 3 little dots. Select those, and then you say reset, and that'll reset the position and everything else there, which makes it super useful. Here on the plane, I'm going to reset that. There we go. And get rid of that one. Okay. Great. Okay. Okay, last week, we had condensed time, and I was really just trying to get us to have something to show for ourselves last week, okay? Now we'll take a little bit more time. Keyframe, animation in Unity. So we're going to go through a better version of the process that we talked about last week. We're going to add some squash and stretch, do some fun things, okay? But now you yourselves, like keyframe animation is one way to make things move in Unity. What's another way to make things move that we just learned today? Physics, yeah, right? And so, yeah, a lot of interactive experiences will include both, right? You've got a paddle that you can move around and then hit a bunch of cubes or whatever that are, bouncing around with physics, stuff like that, right? So there we go. But a couple guidelines here when we're doing keyframe animation. This one is really important. Do not animate the top of the hierarchy. This is a lot of times not totally obvious to students at the beginning, but it will become clearer in a second. Everyone got this one written down? Okay, let me just show you. So don't work along with this. Let me just demonstrate why this is not great. So for instance, I'll grab this new sphere here. I'll go to animations. I'll go to window, or go to the animation window, and I'll say create an animation on this thing. And I'll call this just test for now. There we go. And I'm just going to set some keyframes on this. So here, and let's move it. And we'll move it over. And then we'll make sure it goes back to the same place. There we go. And I got that. Okay. And so if I hit play down here, it's animating. Congratulations. Right? We talked about why this doesn't look like a bounce before, but for right now, that doesn't matter. We're just making it move. Okay? Okay. So we made a game object animate. Great, right? And once you do that, the next inclination is like, okay, well, I made this thing in my game that does this animation. It loops, which we talked about why that's the default. I want some other ones. And so if I come back over here, and then I Control D this, and there we go. Start to make some new bouncing. You're just animating things. Watch what happens when I go into play mode. Wah, wah, wah. Oh, what has happened, Punchy?
Maybe because the XYZ coordinates are all rooted to that center point, so that they're not personalized, it's their own local points.
Ding, 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 ding. Excellent. Yes. So, the animation is in the space of the object with the animator on it. Okay? And so if that is the top of the hierarchy, then that means those are in world space. Those are world coordinates. So even though I duplicated this thing and moved them all around to different places, right, as I click on them, you can see that they have different coordinates over here. When it comes time to play the data, the animation data that is in the animator, right, all of these have identical information here, here, and there, right? And so when it comes time to go into game mode, they all read the same animation clip and move back to that original position. And if I hit play, that's exactly what happens. Does everybody understand this phenomenon, what has just happened here, right? Okay, and so how do we address this? We do exactly what I said. We do not animate at the top, and so you always want to frame it in a positive light. Always make a blank game object at the top of an animation hierarchy. This will allow you to position each object at its own position in world space, because the animation keyframes will be relative to the parent, right? This is why we talked about parenting before, and we talked about this, right? Because this parenting is key to making this idea work here. So a better way to go about this, and I'm just going to delete all these things to sort of clear the table. So let's delete those. Let's come back here, and that test. I'm going to delete the, I'm going to delete the assets, the actual clip and the animator, because I don't want those there polluting everything. I'll go to meshes and put this in here again, like so. And so the first step of animating is to come up here. I want to make a bouncing ball with new sphere. I'm going to select new sphere, come up here, and first I'm going to reset it so that it is at 0, 0, 0. Then I'm going to click over here so that you can see it. And Unity has a really useful command, create empty parent, right? And so it will do exactly what it says. Boom. And so now I have this top level in new sphere is a child of the top level thing. And so up here, I can select this, and we're going to call this bouncing parent, just to be clear. There we go. And we have, there we go. Let's save that. And so now, when I want to go animate, I do not have this selected. That's the top level. If I have that selected and I animate, we're just recreating the problem we just had, right? I select here. Then I come over to animation. Actually, before I select the folder, just to keep my files organized. Now I come over to animation and I say create. And I'm going to call this bounce, squash, stretch. There we go. And save. There we go. So now, if I just add some very quick keyframes here, there, and then up, and then back down. Again, making a seamless loop. Control C, Control V. I have the same data here as here. That means I'll always get a seamless loop. And so now if I hit play, there we go. And more importantly, now if I were to come up here and duplicate, from the parent. So I'll just Control D and move these around like so. There we go. And now if I hit play, ba-da! what we want to have happen in almost all instances, right? I made an animated thing. Now I can easily populate my environment with duplicates of that animated thing. So the key here is really this. Make sure you do this, before you start any keyframe animation in Unity. So you're able to easily move that around or duplicate it throughout your world, your scene, your environment. Sound good? Okay. Now let's make this animation quality. So let's come back and focus on one. And we'll come over here to our curves. And which is it here? Is it this? Is it that? Yeah, so in Unity, it is Unity panel full screen is Shift spacebar. So in Blender, it's Control spacebar. Here, it's Shift spacebar. Takes whichever panel the mouse is on top of and blows that up to full screen. So especially if you're working on a laptop, it makes it much easier to see what you're doing. So I use this all the time in these sort of situations, especially here when I'm trying to, see what's happening in the editor. And then F will frame whatever is currently selected. In this case, it was just that one keyframe. And so I can select all of them. And now if I press F, there we go. It sort of reframes it, so it makes it easy to see what's happening. And somebody who's not Punchy or Arlinka, explain to me why this doesn't, the ball does not look like it's bouncing. How does this graph relate to that? What do we have to change about this graph? Yeah. Right. I mean, in this case, we want the graph to look like a bounce, but what is this doing that is unbounce-like? It's slowing when the ball gets closer to the ground, which is not how gravity works, right? Gravity accelerates you towards the ground until, you hit it. That's the real downside of gravity, right? Is that we keep getting faster until something stops you, right? This idea that we slow down before we hit the ground, it's very ungravity-like.
I think that's a downside of gravity. I don't want to float into the sun.
It was what you were.
And so if I grab our handles here and move them, a little bit of keyframe business. If I grab this and right-click, what do we want here? By default, we have Bezier handles, which looks good. There we go. But when you grab the default Bezier handles in Unity, you'll notice that you cannot. You can change their angle, but you can't pull on them to make them longer. And so in Unity, that is a weighted handle. So if you right-click and go from both tangents weighted, now I get what's like the default Blender handle, where I can make the Bezier handle longer in order to change the degree of curvature here. And so same thing here. Right-click, both weighted. There we go. And so now this is more like what happens in Blender. And so I get this bounce. There we go. And so again, Shift spacebar. Oops, get it out of here. There we go. And now if I hit play, I have achieved bouncing. I want to bounce higher. And so what direction do I need to move this keyframe on the graph if I want to bounce higher? Yeah, up. In this case, up, yes. Because Y is up in Unity, And so this gives me more. If I want to do this, yeah, that's not bad, but a little bit less bouncy. If I grab this one, I go both tangents weighted. Now I can drag these out to give me more of that U shape, which is going to give us a little bit more of that hanging at the top, right? And so here, yeah. The Disney book is called The Illusion of Life, right? And one of the first steps here to creating that illusion is physics, because life exists in the real world. And so we've done that here, sort of step one, in terms of gravity, right? But gravity exists in terms of animation on a continuum. We can go to the left where there's like no gravity, and this is essentially like linear, or we could go to the right where there is exaggerated gravity. And then we're in, what I'll commonly refer to as toon land, toonish, cartoonish, right? Where part of what makes cartoons look exaggerated, and one of the fundamental principles of animation is exaggeration, is their exaggerated gravity. And so this, I would say this looks like a bounce. Does it look like a physically accurate bounce? Sure, kind of, right? I mean, it depends on like, what is this ball made of? And is it inflated? There's a lot of physics detail. But we can exaggerate here by sort of making the U shape even more pronounced. And so grabbing these handles and doing something like this. And so this amount of time that we hang in the air will be hyper real, right? And so now we get that, cartoon level animation where the coyote, runs in the air for a while before he figures out that gravity is going to once again pull him to the bottom of the canyon, right? We get this cartoonishly long time that we're hanging up here, right? So you need to know how to emulate physics. I would say that's level 1. And then level 2 would be exaggerate physics. Now, that's not appropriate in every artistic context, but as an animator, you want to have both things available to you as tools. I want to be able to accurately mimic what happens in the real world with keyframes, but then I also want to be able to play with that and exaggerate it in certain instances. Cool. Cool. Great. Yeah, well, let's leave that there so that we can use that as the basis for our squash and stretch. The other thing I want to call your attention to is this. What is this showing you in the graph editor here? KT? KT? No, J. Sorry, KJ. Yeah, we're looping here, right? So this shows us that happening over and over again. And remember, in Unity, the default for every animation clip is loop, right? Why? What are we making in Unity? How long does the video game last for? Possibly, right? If there's enough battery, I mean, in terms of like actual real world physics, no, there's actually the heat death of the universe out there that's going to happen at some point. And so that will, stop the game at some point. But for our practical purposes, yes, forever Max is right. Like could run forever, right? And so we want everything to continue to loop over and over again. Yes. Did you have a question?
I was going to answer your question.
Okay. The same way, forever?
You said it's supposed to loop because if you want to do an action, like it would have like an awkward sort of glitch.
Okay. The awkward glitch has to do with the beginning and end point of the loop. Okay. So the reality is that all of the animation clips loop, right? And if we don't make the beginning the same as the end, then we get the glitch, right? So to demonstrate that here, I'll move this one so it's like that. And so now because we can see the repeating here on the timeline, this is the glitch, okay? And so if I play this, here's what we get. Actually, I mean, it's going to be, I'll do it like this. Let's do it. So it's a little bit more obvious. It's a little bit tough to see when it's already bouncing so exaggerated. There we go. Right, and so it snaps back to that position. Essentially, it's not animating between here and here. It's just snapping back to that position. And so that's why, right, we always want to make sure that the beginning is the same at the end. The easiest way to achieve that tactically is to just copy the beginning keyframe, come over here to the end, and paste it, and you immediately get a smooth loop, okay? We got this. So with Bezier handles, you need to be careful of this, right? Where we are now past where we set the keyframe. So Bezier handles can result in this. And so this, what's going to happen now? What is the ball going to do that it did not do before? It's going to go through the what? Yeah, through the plane, through the floor, right? This, remember this keyframe, the bottom of the bounce, this Y coordinate is the floor, right? Now we've messed up the Bezier handles so it goes down past the floor. So now we have this, where it goes through the floor, okay? You just need to be aware when this is happening, okay? Sometimes we do want to do a little bit of this in order to give something a little bit of anticipation, sort of like a, rev up before zooming off in one direction or another. It's a useful animation technique. But to have it happen when you're not in control of it is not ideal. And so let's just restore some sort of reasonable bounce here. Okay, great. And let's save that. And I want some color in this project. So I'm going to bring in some materials. And I want my pink here. About like that. Besides the color, we have metallic and smoothness. And so let me go ahead and change this to pink. There we go. And I'll put it on the ball. What is this not like? There we go. We have metallic and smoothness. So these are the two parameters for materials. These are function essentially the same as they do in Blender. You can have a smooth metal that gives us this look, or a rough metal, or you could have the metallic the whole way to the left, and you could have a smooth plasticky surface or a rough plasticky surface, right? And so you can sort of tune those things in. We'll get into this in more detail later, but we've got that so far. Cool. Okay, and then I'll go and do something like this. Why is this giving me this error when I drag these on? That's irritating. You shouldn't run into that, I hope. Let's save our scene. There we go. And this is a little intense. There we go. And I'm going to move this off to the side. Kind of like this. There we go. And I want the camera, let's say right about here. I'm going to make the plane bigger. So I'm going to say 555. There we go. And let's go ahead and make I want the camera here. So I'm going to grab the camera. And what is the shortcut to move the camera to the viewport? Control-Shift-F. There we go. Now we're there. Good. All right. We're on our way. come back and select here. Okay, and we'll do this squash and stretching here in a series of steps. There we go. Okay, in general here, when should the ball squash? When it hits the ground, right? And because our anchor point is at the bottom, this will be easy to do. Because now, what does a squash look like here at the beginning? And so we need to push the top of the ball down, and then the sides of the ball need to go out, right? Because we are squashing in 3D here, right? So which direction is up? Which axis? Y. And so what I do here is I start this off usually by coming out with a number that I'm going to use to sort of subtract down and then push out on the sides, right? Because that's, if it's filled with air, you push down on the top, it smushes out on the sides. So some sort of volume retention. So I'm going to put in 0.8 here to squash it down. So that you see that just kind of like looks like it's making it smaller because I haven't, actually, before I do that, I am going to do that. And then I'm going to turn on my recording here so that I get easily record. Unity telling you something is animated is this. See how these are like red here? That means that this is, the position is animated. And so here, we're going to go in 0.8. And then over here, if I want to squash out by the same factor, or out, what should I change the 1 to? 1.2, right? Because I subtracted 0.2 from the other direction. And so over here, I put 1.2 as well. And so now I have that. And as I go up, I want to stretch in the other direction. And so I move the playhead forward, and I'm going to change this to 1.2, stretching up, and then 0.8 and 0.8 over here. And so now, there we go. And so here, and I am scratching up. Yay! Usually people are excited. There we go. And then at the very top, I will, in this case, sort of return to normal, right? There's no, again, pure physics would be that there's no longer any forces being exerted on the ball. But, I mean, how far down the physics rabbit hole do we want to go, right? Like, there's been this compression, there would be these reverberations or whatever. But again, right, we want to know the basic physics and then be able to amplify it when we want. Yes?
You're infringing on copyright because this looks exactly like Slime Rancher.
Slime Rancher? Okay.
It's okay.
We'll see if I get the YouTube takedown notice on that. Usually as long as I don't play copyrighted music, I don't get it. But like maybe someone will say that. We'll see. So we'll return to normal. So what is normal scale? Yeah, 1, 1, 1, right? And so 1, tab 1 allows me to go. Remember, these are being recorded there, right? And then as we start to move back down towards the ground, we will, in real life physics, would the ball stretch towards the ground? Like maybe infinitesimally, like it's like the gravity is exerting this, but no, like really not, right? Like not in a way that's humanly perceptible. But we are doing, somewhere, we're not doing pure physics, we're doing somewhere along that continuum of exaggerated tune physics, right? And so we will stretch towards the ground. We'll put in a 0.2 here, and then we'll stretch here, 0.8, 0.8, and that is still being recorded. And then as we come down here, we're going to hit the ground, and we'll get back to 1.2, 0.8, there we go, and 1.2. And so there we go. And I'm going to turn the record button off so I don't forget to do that later. And then just use this button. And so, Jana, how is this button different than the button up at the top?
This one is just for the animation.
Yeah, it's just going to play that animation, right? Just this. If there's other stuff happening in the game, we're not going to see it. And so, there we go. Now it looks really slimy. And so in terms of it taking, the illusion of life, we've taken a rather significant step along that continuum, right? For when it was just, especially in terms of games, right? The reason a lot of things look rigid in games is because doing this kind of thing can be more expensive in terms of the computation, again, going back to the real-time rendering. And so doing this, starts to give it, much more of a look. And so now we've got sort of some of the basics in place here. And now a lot of the decisions we need to make come back to the style we want to create as animators, right? And so now it's about looking at what you've got, thinking about how you want it to change, and what changes you need to make here to the graph. And so now we have all of these scale keyframes here, here, and here. And so let me draw this to your attention here. And so this is the Z keyframes. This is the X keyframes. Notice that these are the same, right? These are the out keyframes, okay? And then the Y is the opposite. And so remember how I was making one of them 1.2 and then making the other ones 0.8 and then switching it back and forth like this? That's what this graph is clearly showing you, right? This is the squash. This is the stretch. This is back to normal, right? And then this is the stretch, and that's the squash. We started off with the squash, and so we, again, have maintained that the beginning is the same as the end, so we get this smooth loop. So one of the things that you definitely want to consider doing here is, the ball spends almost no time undeformed in this animation as it currently exists. So coming in here, right-clicking and going weighted now allows us to change that. And so I grab all of these, and then it's not going to let me grab all the Bezier handles at the same time. No, actually, that's probably a poor strategy. This is the, that's 111. All of the scale keyframes overlap here, right? And so this represents, it being undeformed. And so if we want more undeformed time, we simply make another 111. And so I go Control C, Control V, and now between here and here, the ball's scale comes to rest, right? We are undeformed for that amount of time. And so if I grab this, I hold down Shift, I can make sure that it locks it so that I don't accidentally move it up and down. And so now I'll squash and stretch and then spend more time undeformed in the middle. So if we look at this here and play it back, right, so we squash and stretch, and then while we're hanging out at the top, we have some time where we are undeformed there. Another place where you can make artistic decisions is how quickly does the squash and stretch happen, right? And so what if I moved the stretch a little bit closer to the squash? Go ahead and grab this and move it over. Again, I can hold Shift because I do not want to move these like this, right? If I do this here, it's not going to change the position, it's going to change the scale, right? And so now it's going to look, yeah, it does some weird thing there. So if I come back over here and just Control Z my way out of that, the other thing that you could do is come back to the dope sheet view. And if you're just moving around the blocks, you can just blocks of keyframes here. It's maybe sometimes easier to do it this way, right? But you need to remember what's what. Squash, stretch, normal, normal, right? And so sometimes it's easy. If you know what they are, then you're good. But if you're not sure, looking over here, you can clearly see what's what, right? And so what if I wanted the squash and stretch to be much more compressed around the impact point? And so if I come back to the dope sheet here and move these over this way and then take these, in Unity, there's a really nice feature here where if I select a bunch of them like this, if I grab this bar here, I can squish not the scale, I'm squishing the amount of time that these keyframes take up here. And so now I've moved this and this much closer to the impact point. And so if we look at this now, it looks like something like this. Right? So way snappier, right? We just whoosh, just a little bit of squash and stretch happening right as we get close to the ground. But, okay, there are levels to this, right? So I would say, just making sure that it looks like it has gravity, that's the minimum bar you need to clear as animators. Like everyone, that's the price of admission. You need to understand that part. Once we get into this now, a lot of this is about thinking about how do you want this particular animation stylized? And there's some more steps that we can take here, which may be really interesting. Where are we at? 540. Okay, so one would be we could exaggerate the squash and stretch a little bit more. So let's give it a little bit more time. Again, I'm not going to move the end. I'm just sort of moving this. So to exaggerate it, if I come back to this graph and over here like this, press F to frame this stuff. The exaggeration of the squash and stretch is the distance between these keyframes vertically, okay? And so if I want it to smush more and stretch more, I need to move the distance between these things. So if I grab this one and move these up, is it going to let me do this? Why would it not let me do that? I have this. I should be able to. There we go. Move that up to, what if I hold down Control? No, let's say right about, I don't know, there. I want it to be symmetrical in this case. That's not the case for every animation, but for most animations. And so I do this, right? So I have the same basic timing, but now you'll see that when I smush way more there, and I stretch way more, right? And so you could push this to some crazy levels here if we wanted to indeed do this even more. Again, keeping it symmetrical is important for preserving the volume in this particular animation. And so if I do that and then do this again, all right, we're squashing down to practically pancake here, right? So now, I mean, you want to pay attention to this. This is a phenomenon, a non-physics-based phenomenon that I refer to as pre-squash, right? Where like this doesn't make any physics sense, right? The ball is deforming before it hits the ground, right? Where in actual physics, like that doesn't happen. But you can get away with a bunch of pre-squash here because it's happening quickly, right? So there's that. If that was really bothering me, I could just simply move some of these keyframes closer over here, like so. And again, this time that we're actually undeformed here, if I start to get rid of that or make it shorter, so there's a lot to play around with here. This is pretty exaggerated. I'm going to dial it back a little bit.
Now you just need to add some eyes and it will look just like a slime.
You should do that.
And we talked previously about, the wobble. What would a wobble look like? A wobble is just continuing reverberating squash and stretch, right? And so if I take these keyframes here, Control C, and paste them here, Control V, there we go. And so now if I look at this, it will squash and stretch and then come back down, right? We're very elastic at this point. And so here, if I grab these and move these in, so it's like a bigger squash and stretch and then a less squash and stretch over there. Let's expand them out into time. Let's move this. Whoops. You got to make sure you probably draw a square over there. And so now we're going to squash and stretch and then have a wobble and then a bigger squash and stretch towards the end. And so here we get to this. Yeah, so it's very vibratory. There we go. We've made this provocative. Okay. We want animation, a lot of steps and layers there, right? So the basic things I want to see you clear is like have some squashing and stretching, make sure it looks like there's gravity, and then make some decisions along the wobble, extended, exaggerated, squash and stretch spectrum, to make something interesting. But now we also want to make it interactive, right? So that we want to take the interactivity a step further than we did last time. And so before we just clicked on it and it started bouncing, and that's really all we had time for, right? We were going to go a little bit further here, and we're going to make it so that you click and you get one bounce, and then it stops. And then if you click on it again, so click to bounce, right? Essentially, like click on it because we can, once we've got it, we have something that we can duplicate now. We can populate a whole scene with these balls that we can click on to make them bounce. It'll be great. It's going to hold on, right? So here we go. But in order to do that, we're not starting from an undeformed ball, which is what we would, for that kind of thing, is what we would want to start from. And so let's set up a little bit of that here. And so I'm going to grab all these keyframes and I'm going to move them over a little bit. And then I come back here to the beginning. And let's set up an undeformed ball here. And the undeformed ball scale is 1, 1, 1. 1, 1, 1. There we go. And I didn't have recording on. So you see that this is not recorded a keyframe. I can also right click over here and say add key. And so that'll manually add it. And this is like the stopwatch in After Effects, right? Where once this is on, any parameter that you change or adjust will automatically get keyframed, okay? If you have to add a key manually, right click, add key. And so now it stays put. And then we get this, quote unquote, for free, right? Here it is at the beginning. This is it pre-squashing, right? Where it is sort of moving down before it gets launched into the air there. And so in this case, that looks, I think, good in that it really anthropomorphizes the ball, right? It makes it seem like because if it were like a living slime ball creature, it would need to gain some momentum before it launched itself into the air, right? And so there it goes. And same thing at the end, right? We want the ball to come to rest. And so at the end here, we want to come back to 1, 1, 1, like so. And probably move that a little bit closer over here. And so now I get this. So again, it's looping. It would stop there, right? That's what we're going to make it do. And so we have it there, and there it launches itself in and squashes back down, and we have that. Once you have this extra bit of time here at the end, between, remember, these are the position keyframes and these are the scale keyframes. We kept these aligned before. Now we've got this extra bit of time where we're not moving. And so this amount of time here, this is important to see on the graph. Once we've done this, is I select these so that we can see this. Boom. Here, check this out. We have hit the ground and we are returning to normal on the ground. This amount of time here was not available to us before because we added this extra scale keyframe here past the impact on the ground. And so now we can move these things relative to this time. And so this can help us address that pre-squash issue that we were having before. If we grab these and certainly move them over a little bit here, like so. Now if we look at this, here at the end, we're right there. So it makes the squash happen after we hit the ground, right? And so this makes it look more motivated by physics, right? Whereas before, when we had to make the seamless loop, this was not, available in the same way, right? And so part of doing cartoony bounces like this is this extra bit of time. This is counterintuitive to a lot of students. It's like there's this amount of time where the ball, like sits on the ground, but, the squash and stretch makes it seem like physics is still active and then goes back into the air there. And then, if we want the ball to like really try hard, right, we take this is the initial position, this is the squash beginning of the bounce. And so if we were to delay these things, actually move them all over, now we get this extended period of time here. So it's, right, it's really got to try really hard. Right. Just whatever, again, you need to make your own decisions about, what kind of character the ball has there at that point. Cool. Okay, we've got that in place. Good. Okay, we've got a loop that starts with a undeformed ball, and we've got a loop that ends with an undeformed ball. That's going to be the key, given the way that we're going to make it interactive, okay? We don't want it smushed at either end. All of that needs to happen in between the start and the end. Okay, let's save that. I feel good about the animation. Let's address the interactivity. So, with that in mind, a few things here. This is a mesh we brought in, not a primitive. What did I tell you before that this does not have that we need to add? What component does it not have? Collider, exactly. So we need to add that. And so down here, we just type sphere. There it is. Now we get that green cage over here. Notice again, if you hit the play on the animation, this collider itself doesn't squash and stretch, but that, like the play, you're not seeing that in the game. It's a limitation of colliders, okay? But why do we need that? It's because the collider is necessary for the click script, right? In order to click on the thing, that's like a form of collision, and it needs to have something on there. Okay, good. And that's happening. And so now we need to add the same script that we used last time to get the interactivity happening. So we come to our scripts. You should already have it here, right? And this, actually, let's manage the animator first. So we've got this selected, and here we go. The animator. Okay, so remember this from last time? Okay, we're going to do a similar sort of thing here with this one. We want to, we need a second state, right? Remember the name for this? This is the animator. There's a bunch of names here. This is the animator, that's the name of the component. The other name is, you see this referred to as the animation controller. The other name you'll hear is what this is. This is a state machine. Okay, all of those things up here. And we need a second blank state. Right click and say create state, empty. There we go. And this is going to be stop so that we can manage that. There we go. And if we don't want the ball to animate at the beginning, we right click and we say set as default. There we go. And what we can do here is before we told the script to play this one, right? But when you just play one state, what does that state do? What is the default for any animation clip? an idle is a loop. It loops, right? And that's what we had last week, right? We clicked on the ball and then the ball just kept looping, right? What we want this week is we want to play one bounce and then stop, right? And so what we need to do here is we need to transition from here to here. And so you right click on this, you say make transition. That gives you a little arrow that then you can connect to this state, right? And so we get this, right? So this is when the game starts. When we start the game, do nothing. And then when we play this animation, play it once and then go to stop here. Okay, that's what this is signifying. The part where we tell this to play, that's where we need the script. This is complicated. It definitely seems overly complicated for what we're getting, right? We're clicking on a ball and it's bouncing. This seems like a lot of rigmarole. It does. In this case, I really try to insulate you guys from unnecessary, arbitrary complexity for these things because, frankly, it's not worth learning. It's the complexity is the result of a bunch of arbitrary design decisions that either Unity designers have made or someone else, right? But in this case, the complexity does allow, the complication allows for greater complexity later on, right? It's probably too much just for ball bouncing, but later when we want to make a character or do anything more interesting, all of this is much more useful then. So there we are. We've got this, and so now if we've done this correctly, we should have our ball do absolutely nothing. And it does do absolutely nothing. We have succeeded in nothing. Okay, so what I just did there, also my other big piece of advice, which I'll keep telling you every week, is avoid the what? Bang. Very good. Avoid the big bang, right? Which is where, what is the big bang? You're like getting a bunch of work done, a whole lot of steps, and then you go up to the top and you're like, I hope this is going to work. Press the Unity button, right? Yeah, doesn't work. And then it's the next part that's the problem. You're like, ugh, what part of this doesn't work? Well, I just did like 700 things, so I guess it could be any of those. And so this is why we don't want to do this, right? I did the animation. I checked the animation. It was animating exactly how we want, right? And now I set up the animator. And then I made a hypothesis, right? So especially at the beginning, I think some sort of basic scientific thinking about this stuff, especially when you don't know it that well, is very useful, right? Like, okay, I think I know how this should work. Set up a test and then test it. Is that correct or not correct? And so here I've done the same thing. And based on this, my hypothesis is that the game should start and the ball should do nothing. And so let me test that. And that is indeed what we have done. Absolutely nothing, right? It starts the game and then you see it's looping through the stop animation. The stop animation is just blank. It's just, just sitting there. Okay, so now we need to be able to play this animation, and that's where our script comes in. And so now we have a new wrinkle that we didn't have on Monday. We have the script, which is here, the click event on Collider. But now our object is more complex. It has two parts. It has this and this. And so here's what the parent object looks like, and here's what the child object looks like. And so now we need to make a decision of which of the objects do we put the script on. What is your intuition here? Yeah, you put it, we're controlling the animator. The script should be on the object with the animator, right? And so here, remember I can do this. I can just drag it over here, or I can search on the bottom thing there. And so here, once again, what is the structural thing that's working here? This is a Unity event, essentially a signal that says do something, and you get to control what the something is, okay? And what do we need to talk to? In this case, we need to talk to ourself. So I need to drag that in. I'm going to save. And then we need to choose which component to talk to. That's going to be the animator. And then what do we want to tell the animator to do? We want to play string. Okay? But if I do this, I hit play, and then I click on the ball, is it giving me an error? No, it's not. But nothing's happening. Why is nothing happening? It is receiving the message play, but we have not told it which animation to play. There's only one animation in our example here, but in the future there'll be lots of them, which is why you need to refer to them by name. And so in this case, I named this something longer. So I'm just going to copy the name of it and then paste it over here to make sure I don't screw up typing it. Okay? Because this is, that can happen. And if you don't get it exactly the same as the name, it won't work. And so now we've got everything in place. Let's test it again. Yay! Right, so we play once. You see what's happening? That's why this window is complex here at the beginning, but I think it's really great in that you can see what the heck is happening when the game is running. So when I hit play, you see it play that animation, and then it even animates the little transitions here. See that? So now we have made something that's very reusable, right? This could be something in our environment, right? Because right now we're clicking on it, but all of the stuff I've showed you, these skills and structures are transferable to many, many other strategies, right? Right now we're clicking on it. It could, with very, very minor changes, it could be the player just bumping in to this thing. That makes it bounce, right? And so as the player's moving around the scene, all of these things will be interactive, creating this much more rich interactive experience, right? And we've done it correctly over here in that we made something that can be reused in the environment, right? And so now I can do this. I can Control D this sphere. There we go. And then hit play, and all of the work transfers here. Endless fun. Both things, animation and interactivity there. Class is adjourned. Yeah, right. So again, over here, I made sure to duplicate the top level, right? Not the thing below it. And I'm able to move those around throughout the entire space here. Each of them are separate here, but yeah. Okay, let's save that. So top level, once again, animate, right? Then we essentially did the animation controller. We got that set up, right? Then we added the script and configured that for what it is that we wanted. Okay. To show you some of the other things that could happen here is, for instance, let me go ahead and make something that's visually different. Let's make a cube. There we go. Let's put this over here. And I'm just gonna move this down and, I don't know, over. So how we can use a single Unity event for multiple things. So here, this foreground sphere, I've got, it is playing the squash and stretch, right? And so when does this event happen? When we click on this collider, it'll execute all of the stuff in this list. Right now, this is not a list. It is just one thing. What if we want to do more stuff? So for instance, I'll hit plus here, and now I'm going to make this cube disappear, right? And so we'll take the cube and drag it into here. Remember, this field here, this is who? Which other game object am I communicating with here? And then this is going to be, what do you want me, which component do I want to talk to? And so I'm going to go to game object set active. Okay, and so this set active function, okay, there's a lot of functions over here. I wish there was some way for me to make this list not as long in the interface, because it will really only use a handful of them here at the beginning, but this is useful, okay? But I'll try to tell you which ones are most useful. But set active is the equivalent of checking or unchecking this box at the top, essentially turning an object on or off. And so what we're going to do to this cube is we're going to go to game object, set active, and then instead of a string, a name to fill in, you see that this gives us a checkbox. Okay? And so this checkbox essentially is essentially that checkbox at the very top. Do you want it to be checked or unchecked? Right? And so it can be this or this. If I do, okay, let's uncheck it. And so now, if I hit play, when I click on this ball, we will do two things. What are those two things? What's the first thing that we just spent the whole class doing? It's going to bounce. What is this? What is the other thing that's going to happen? It'll stop. What is it going to do to the cube? Okay, we'll interact, but I mean, more specifically. Okay, here we go. Watch. Ready? Right. It told the cube to set active off. It went away. Turned off, right? When I reset the game, now the script is not set up so that if I click it again, the cube would come back. Essentially, it's sending a single message. It's just, it's off, and it'll just send the off message again. If you send off to an off thing, it'll just stay off. So there's that. But this structure is what I would write down in my notes, right? Any game object plus set active, this, you can build a lot of functionality with just this, right? Just by being able to grab Unity events and turn things on and off, you can do a whole lot of stuff, right? You can, between these two things, easily make door animations, have new parts of the world open up, all sorts of things like this, right? Just being able to turn stuff on and off helps great, right? You walk into a specific area, the collider sends an event telling the enemy spawner to turn on. All of a sudden the room is filling with enemy goblins or zombies or whatever they are, right? A lot of just turning things on and off here. Yeah. So for instance, we could do something fun, like we'll do the opposite. We'll turn another light on. And so here, yeah, we'll make a party ball. So let's make this one a different color. There we go. And then on this one down here, let's take something. One light that we haven't worked with is the spotlight, which is different than it's more like the point light. It just points in a specific direction. And so both rotating and moving matters for the spotlight. But if I were to turn this on, and again, what is it missing that it really needs? What am I not seeing? Shadows. Turn on shadows. There we go. Let's give it like an alert color. There we go. Something like that. Let's bring it down further. Let's move it this way. There we go. Move it up a little bit. And there we go. Okay, let's animate it. And so on this light, I'm going to go ahead and add, let's make sure we select the animation folder so that all the animations go in there. And then I have the light selected, and I'll say create. There we go, and we'll call this light. Move, spin, and there we go. And we'll just rotate it. There we go, kind of there. And then over this way. There we go. And then we'll have it sweep back. Again, making a seamless loop. Control C, Control V. There we go. We want that. Awesome. Okay, and so now when I tell the green ball to bounce, I want the spotlight to turn on. And I don't need to do anything to the animation. If I just hit play, the animation, I didn't do anything to set up the animation, so it's just doing its default thing. The default thing is to just repeat and start when the game starts. Or start when the object starts, okay, when the object is turned on. And so in our case here, we want the green ball to enable this light. I'm going to take the spotlight and turn it off. There we go. It's off. And so now on the green ball, I'm going to select this green ball here. There we go. And come down here and add a plus to talk to another object. This spotlight. And again, game object, set active. Do I want this box checked or unchecked?
Unchecked, so it could be off by default.
Wait, you're saying checked or unchecked?
Unchecked, so it could be off by default.
Okay, the default is its current state, right? What message do we want to send to it when we click on the ball?
Turn on.
To turn on. So we want it checked in this case, right? And so now, if we save and hit play, this ball makes the cube disappear. This ball turns on the party light. Now, again, the message remains the same. Given our current setup, it just sends, it does it again. It just sends the on message again, so it just stays on, okay? But we're starting to get is this starting to reveal itself to you in terms of like the amount we can get done here with this, right? And again, this list of things you want to have happen when you trigger the ball is as long as you want it to be, right? And so, for instance, this could also turn the cube back on, right? So here it is, and cube set active on. And so now we have a situation where this one would turn the cube off, and then this one would turn the cube back on. Off, on, off, on, off, on, off, on. Making sense now? So this can get much, much, much longer, right? We can do as many things as we would want here. So right now, all of these things happen when we click on something that has this collider on it, right? But we can do something else. Let's, where are we at here? 6:14, almost over. Let me just do one more thing. We will have a lot of time on Wednesday. Let's just do one thing. So that's one way to send an event, is that script that I gave you, okay? In another week, I'll give you, it's like a whole program of like, I don't know, 20 scripts that really cover a whole bunch of different ways in which you can send events in order to program a ton more different things, right? We're not writing code, but it's still programming, right? You're building, what is this word? There's no H. Algorithm, just set of instructions, right? A lot of times it has a really mathy connotation, but it's just instructions. I'm not asking you to be good at math. All the math that needed to happen to do all this stuff, that is in place. Really smart people have figured all that stuff out and put it in place. What you need to be good at here is thinking in a clear series of steps. None of it has anything particularly to do with math, right? When we start moving things around, maybe a little bit. But for right now, just being able to clearly think, okay, when I click this, this should happen, and this should happen, right? If you can wrap your mind around that clear sequence of events, that's going to pay very big dividends here. Okay, and let's make one more thing. We're going to send an event a different way. We're clicking on this thing. What is UI? User interface, right? And so user interface in Unity can take the form of text, obviously, just any sort of message on there, or a button, right? A button is a common part of user interface. In Unity, buttons can send Unity events that look a lot like what we're talking about here. So, for instance, how do I make any new user interface here? I come over here and I hit plus. Oh my gosh, why does this do this? This is so annoying. Okay, there it is. Every time I press it, the window is appearing on the other monitor, which you can't see and doesn't go out on the broadcast, which is not ideal. Anyways, down here, you may be tempted to go to UI Toolkit. Do not do that. Okay, UI Toolkit is like a newer. Just don't do it. Okay, it's like a different thing. Down here at UI is where we want to go. And over here, let's go ahead and grab a button. And so if I say button, watch what happens. Yeah, whoa, what's happening? So this is a strange thing to get used to here, right? Like, this is the button. Why is it gigantic in my scene? It's in the sort of canvas area here. So you notice I made a button and I've got some new things. I've got this event system, I've got a button object, and I've got the canvas. The thing you should write down in your notes is all the UI goes underneath the canvas object. Okay, so it's like the container for all of the buttons, text, stuff that appears over top of the game. Okay, and so yeah, I'm gonna grab this button here. Again, I can't click here because this is the game view. How do I move it over here? I can select the canvas and then press F, and it'll zoom out. And this is what's going on. This gigantic square here in scene space, this represents the current game, like the overlay on top of the game. And so if I select the button here and use this, you see I can move it around the space, okay? And so this is like an overlay that goes on top. It's a little weird, but yeah. So there's that. Cool. And then over here, you may have noticed when I select the button, I've got a bunch of stuff here about how the button is styled and all sorts of stuff like that. I could change the text. Why am I not seeing the text? It should be visible. Is this facing the wrong direction or something? I'm not going to worry about that for right now. Anyways, I've got this button over here. You may have noticed this. This is another Unity event, right? And so this is the Unity event that's going to be sent when we click the button, right? And so here we could set up whatever we want to do. And so, for instance, here we'll make this button. When you press the button, all three balls bounce at the same time. So here's what we're going to do. We're going to plus, 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 and we'll drag in each sphere. Make sure I go to animator, string. There we go. And let me grab the correct. How do I get back to my world size? Select something, come over here, press F. It'll zoom in. Let's grab the animator. I want to make sure I get this correct. There we go, Control C. And come back to this button. There we go. Here, F, there we go, zoomed out. Great, and so there we go. And same thing here. We'll talk to this sphere. Animator, play that one. And the third sphere. Animator, play. There we go. And let's save and test. There we go. And so all the other functionality should remain the same. This one makes the sphere go away, or the cube rather. This one turns on that light. And then the button, boom, makes all three trigger their animations at the same time. Right? So I'm doing a lot of stuff, interactive stuff now, just using Unity events, right? Triggered by either clicking on the ball or clicking on this button, right? And then once we start to expand this, you have a player in the game, and the player enters an area. That sends a Unity event. And then, turn on the lights in the room, make the lights flicker, turn on the boss object that's, about to attack them in that level, or, anything really. A bunch of stuff here, right? So we got a lot of both animation and interactivity here in everything that's happening. So just turning things on and off, being able to wire up different buttons. We made some user interface. We did a much better job animating the ball, and we started to explore all sorts of different kinds of squash and stretch. Oh, I didn't import if you make a new button, you get this window here that says import TMP essentials. Yes, you need to do that. You do not need to click this. So click that first one. Once you do that, the name of the button or the text will show up here, and then you can change set text to whatever you want. There we go. And so now, there we go, and turn this on. That's why the text was not showing up. Boom, everybody bounces. Sound good? Okay, that was a lot, but yeah. Again, what's due tomorrow night is just what we talked about on Wednesday, okay? We're building on that here, but this stuff will be due a week from tomorrow, because we're gonna look at everyone's presentation videos on Wednesday just to start that process, and then I'll continue on this journey here, adding a few more wrinkles of things we can do here. Sound good? Everybody excited? Yeah? Okay. All right. Stay calm. People getting a little rowdy. Okay, great. All right, let's call it there. And yeah, remember Fabio the tutor is available tomorrow on Discord, right? And so he's one person. If you have questions for him, my strategic advice would be get in there early rather than at the very end of his tutoring time as we creep closer to the 8 o'clock deadline for the assignment to be turned in. Make sense? Right. So in case I haven't made this clear, right, like they're due on Tuesday night. Like part of me putting it at 8 o'clock is me encouraging you to have some sort of quasi-normal sleep habit, right? And not stay up all night working on this versus turning it in the following morning. But I'm not on Discord Tuesday nights answering questions. I am on Discord throughout the week before, during the day, and in class answering questions. Great, but like not at the last minute. So I would get started sooner, especially if you haven't done the Unity installation stuff and everything. Make sure you get all that in place. And then computers. Everybody has a computer that's going to work here. You either requested from one from the school or you figured out your computer situation. That's a school computer, isn't it? Did you get it already or no?
It's my other computer.
Oh, it's your other computer. Okay, and that's a PC. HP. Yeah, that's good. Yeah, because you had the Mac, right?
Yeah, I had a Mac.
Yeah.
I just had an older Mac.
Yeah. The Mac. It just when we go to make an actual game, it ends up being a real hassle.